Good morning, guys. So this is the second week, right? So today we will discuss complex numbers, right? And you guys know that, let's say you have a quadratic equation, x squared plus 1 equal to 0. So how do you solve this quadratic equation? How do you solve this equation? You move 1 to the right side, right? So you subtract 1 from both sides. You cross them out, right? So that will give you x squared equal to -1. Is that right? So let's see, if you have x squared equal to 4, so what are the values of x? How do you find the values of x from here? You simply do x equal to plus or minus radical 4, is that right? Right? And then you will get the value of x equals to plus or minus, what is radical 4? 2? 2. Now you do the same thing here. If you do that, you will get x equal to plus or minus radical -1, right? Now this radical -1, this, or square root of -1, is this real number? What do you think? Is radical -1 a real number? No, right? So this is not a real number. So radical of any negative number is not a real number. And we denote that number, we have a certain notation. We denote this radical -1 by I. And this I stands for imaginary number, okay? This I is what? Imaginary. So the radical -1 is an imaginary number. Did you get it? Okay. So if we got I equal to radical -1, right? If we square this on both sides, you square this on both sides. So what is radical -1 squared? -1, right? Is that right? So now you see I squared equal to -1. So the value of I squared is -1. If you want to find the value of I cubed, so let's say you have a I cubed, this is I squared times I, is that right? You know that because when you have x cubed, what is this? X times x times x, right? If you have I cubed, you can rewrite I times I times I. Make sense? And you guys know I times I is I squared, right? So I squared times I. Are you with me? So what is I squared? What is the value of I squared? -1. So -1 times I, which is what? -I. You see that? So I cube equal to negative I. So you can express I cube in terms of I. So I cube equals to negative I. See that? Did you get it? Good. Now if you have I to the power 4, this I to the power 4 is I square. You know, if this is the product of I times I times I times what? I. Is that right? And this I times I square, and this I times I is again what? I square. Right? So now, what is the value of I square? What is the value of I square? What is this? Negative 1. So this is negative 1 times negative 1. So what is negative 1 times negative 1? 1. See that? So the value of I to the power 4 is positive 1. Right? Right? So if you want to find I to the power 5, so this is, you can write this as I times I times I times I times I. So I times I is I square. And you see this I times I square. And this I times I is I square. And you have I. And you know the value of I square is negative 1. So negative 1 times negative 1 times I. Are you guys with me? Did you see that? And now negative times negative positive. This negative 1 times negative 1 is positive 1. So positive 1 times I is simply what? I. So I to the power 5 is I. Or you can proceed like this, okay? Or you can. So you see I to the power 5, I can rewrite this as I to the power 4 times I. I to the power 4 times I, and you guys know that I to the power 4 is 1, right? So this is 1 times I, this is equal to I. That makes sense? Yes? So now you see, you can calculate, you can evaluate any power of I. Okay, if I have, let's say, I to the power 58, I want to evaluate this. I want to rewrite this, if possible, in terms of I. Or if not, then I will evaluate. I will find the value of I to the power 58. Okay? So now, hey, you know the value of I to the power 4. You know the value of I to the power 2, I square. So you can rewrite this either in terms of I square or in terms of I to the power 4. Because you know the value of I to the power 4, right? What is the value of I to the power 4? 1. So now what you can do here, so I think it's better to express in terms of I square. Look here, if I express in terms of I square, can you tell me what power of I square? Okay, what is the number when you raise I square to that number, give you I to the power 58? You see what I'm talking, right? I to the power what? Sorry, I square to the power what number gives you I to the power 58? Do you know that? So simply you divide 58 by 2, guys. Yeah, you got it. 29. You know that, right? You 2 to the 2 times 2 is 4. So it's 5 minus 4 is 1. You bring down 8. So 2 times 9 is what? 18. See that? So now this is I squared to the power 29 is 58. Make sense? Are you guys with me? And now, hey, what is the value of I squared? What is the value of I squared? -1. How that is -1? Because you see, you remember that? We solved x squared plus 1 equal to, this is the quadratic equation, is that right? Right? We solve it. You move 1 to the right side. So we have x squared equal to -1, right? And you got x equal to plus or minus radical -1, is that right? And this radical -1, this is not a real number. This is not a real number, right? This is an imaginary number, right? We denote this by I. And then when you square this on both sides, you see you will get -1. So now this is -1 raised to the power 29. And now, hey, do you know that if you have a negative number and if you raise to the odd power, you have a, let me write down here, if you have a negative number, or let me write down this, -1 to the power odd power is -1. -1 to the even power is what? +1. Right? That makes sense? When you multiply negative number even times, it will give you positive. So now you see this 29, is this odd or even? Odd. So that means it will be what? -1. Make sense? Are you guys with me? So now you see, now similarly, you can evaluate any power. Let's say I want to evaluate I to the power 99. Right? I want to evaluate I to the power 99. You know what I mean, right? So the idea here is you try to express I to the power 99 in terms of I square, in terms of I square. So you see that is, you divide 99 by 2. Are you guys with me? Bless you. What I'm going to do here, I will rewrite this in terms of I square. Okay? So now you divide 99 by 2. You know 2 times 4 is 8. Right? What is that? Is 1. You bring it down. This is 19. And this 2 times 9. This is 18. So this is 1. Is that right? Right? What is the remainder? The remainder is 1, right? So that is same as now I square to the power 49. 49, right? Times I to the power 1, which is, you know, like I to the power 1 is what? I. Makes sense? This is 2 times 49 is 98. I to the power 98 times I is I to the power 99. Right? So now you'll have, and you guys know the value of I square. What is the value of I square? -1, right? To the power 49 times I. And I told you if you have a -1 to the power odd number, that will give you -1. So this is -1 times I, which is what? What is -1 times I? Negative I. See that? I to the power 99 is equal to -I. Right? Did that make sense here? So I is an imaginary number, okay? So now, let me define the complex number. Any numbers in the form of a plus bi is a complex number. Okay, if you have a number in the form of a plus bi, Okay, so A is called real part. So this is real part, and B is called imaginary part, okay? Imaginary part. So any numbers in the form of A plus BI where A is called real part and B is called imaginary part is called complex number. You see that? Can you look at the slides? If A and B are real numbers, then any number of the form A plus BI is a complex number. So can you give me one example? And you guys know that this A and B are real numbers, right? A and B are real numbers, is that right? So that means, let's say 3 plus 4i. This is a complex number, right? Negative 2 minus 4i. This is a complex number. 3 is the real part, 4 is the imaginary part. What is the real part here? Negative 2 is a real part and negative 4 is an imaginary part. Make sense, guys? Good. Okay. So now, look here. If you have a two complex number, A plus BI and C plus DI, they are equal if the real parts are equal and imaginary parts are equal. So that means if you have A plus BI equal to C plus DI, then that is true if and only if A equal to C and B equal to D. That makes sense, guys? Okay. So you see, for the complex number, if the imaginary part is 0, so look here. You have a complex number A plus BI. So this B is the imaginary part. If B equal to 0, then this will be A plus 0 times I, which is A plus, the 0 times I is 0, which is A, and this is a real number, right? Right? So now what you need to know is, if you have a complex number A plus BI, where B equal to 0, then you will get a real number. So that means every real number is a complex number, but not vice versa. You see what I'm talking? Every real number is a complex number with an imaginary part 0. Like for example, give me the example of real number. Let's say 14. Is this complex number? Can you write this in the form of A plus BI? Yes? How do you write that? This is 14 plus 0 times I, right? Right? So now this is in the form of A plus what? BI. So now that's why every real number is a complex number. But not vice versa. So that means every complex number is not a real number. So are you guys with me? So the real number is a subset of complex number. Make sense? Good. So now the set of real numbers is a subset of the set of complex number, okay? If A equal to 0 and B is not equal to 0, then you will have a pure imaginary part. If the real part is 0, now look here, if A equal to, this is your complex number. If A equal to 0 and B is not equal to 0. If A equal to 0 and B is not equal to 0, then it will be 0 plus BI, and which is BI, is that right? So this is called what? Pure imaginary number. BI is pure imaginary number. So like for example, look here, negative 2i, right? Positive 7i, negative I, 3i. So they are examples. They are examples of pure imaginary numbers. The idea is clear. If you have a real part 0, it will be pure imaginary number, right? If you have an imaginary part 0, it will be a real number, right? Okay. So now this form, so if you have a complex number either like this, either like pure imaginary number or a number where A and B both not equal to 0. So they are called non-real complex number. So these are examples of, pure imaginary number, pure imaginary numbers. Are you guys with me? And they are also called non-real complex. Also called non-real complex numbers. Okay? Are you guys with me? So they are pure imaginary numbers. They are also called non-real because the real part is 0. You see what I'm talking? The real part is 0. So that's why they are non-real complex number. Or if you have a complex number A plus BI where A is not equal to 0 and B is not equal to 0. Both real part and complex part are not equal to 0. Like this. You might have 3 plus 4i. What is the real part here? 3. What is the imaginary part here? 4. They are both non-zero, is that right? So they are also called what? Non-real complex. Non-real complex numbers. Or I can show you the chart here. Okay, so let me show you here. So this is complex. Complex numbers. So you have a real complex, You have a real complex number and you have a non-real complex. Non-real complex numbers. And this non-real also, two types. One is what? Pure imaginary, right? So this non-real complex also have you have a pure just like a, this is also like a, only one, this is pure imaginary. So what you need to know is every pure imaginary number is also a what? Non-real complex number. Okay? So, okay, so now let me, and then if you have a complex number in the form of a plus bi, so that is called the standard form. The standard form is this. So this is also called a standard form. So this is a standard form, okay? 3 plus 4i. Any questions so far? Did I make sense here? Yes? Good. Look here. So you have a real numbers, you have a non-real complex numbers, right? You see? Look here. So real numbers, to the left hand side, you see the rectangle on the left side. So first you see the bigger rectangle, okay? So that represents the what? Complex numbers. Right? And then you divide the bigger rectangles into two halves. One is for real numbers, another one for what? Non-real complex numbers. Right? And then on the left side, the half rectangle on the left side is for the real numbers. Is that right? And now look here. You see the natural numbers on the bottom? A smaller rectangle, you see that? Natural numbers. Now the whole numbers, if you add 0 to the natural numbers, it will make a what? Set of whole numbers, right? Natural numbers is the set of counting numbers. 1, 2, 3, 4, 5, 6, 7, 8. You keep on going, okay? It never stops, right? So that's the what? Natural numbers. And when you add when you add 0 with the natural numbers, that will make a set of whole numbers. So every natural number is a whole number, but not vice versa. So whole number is bigger because it has one extra element, one extra number, 0. Okay? So now you can say that the set of natural numbers is a subset of whole numbers. Make sense? And then you go to the integers. So that means with the set of whole numbers, you add negative numbers. Then you have integers. Right? You see that? 0, plus 1, minus 1, plus 2, negative 2, 3, negative 3, 4, negative 4, 5, negative 5, 6, negative 6. You keep on going, okay? So that's the integer. So now, every natural number is an integer. Every whole number is an integer. The set of natural numbers is the subset of integer. The set of whole number is also the subset of integers. Make sense? Now, go to the bigger set, rational numbers, in the form of quotient, like A over B or P over Q. The rational, if you want to find the rational number, it is defined as the set of P over Q such that it's in the form of the fraction. Okay, such that P and Q are integers. Right? And then this denominator Q is not equal to 0. So this is the set of rational. It's bigger. This set is bigger than the what? Set of integer. Every integer is a rational number. You see what I'm talking, right? Let's say if I pick like a -2, this is an integer, right? I can write down this as what? -2/1. You see that? -2 is an integer, 1 is an integer, right? And the denominator is not equal to 0. You see that? So every integer has a denominator 1. Is that right? It can be written in the form of P over Q, where the denominator is not equal to 0. Does that make sense? Okay. So now and then the numbers which are not rational are called irrational. And the rational and irrational, they together make the set of real. You see that? Rational and this is irrational, and they make a what? Real. And then you have a non-real complex numbers. And in a non-real complex number, if the real part is 0, that will make a pure imaginary number. Did you say that? Real part is 0. So that means A is 0. So 3i, -i, 4i, 5i, 6i, 7i, -100i. Those are pure imaginary number. And they all together make the what? Complex number. So the complex number is the what? The biggest set. Right? So now you see that the set of real number is subset of the what? Set of complex number. Are you guys with me? The set of pure imaginary numbers is also the subset of the what? Non-real complex numbers. Or you see, is also the subset of what? Complex numbers, right? Okay, anyway. So now I will take you to this. Okay, so if you have if A is positive, so let me write down here. If you have A positive, A is bigger than 0, right? Positive means. If you have a radical of -A, so this is, you see this is same as radical of -1 times radical of A, because you know that you have a radical of -A, this is same as radical of -1 times A, and this is same as radical of -1 times radical of A, right? And this radical of -1 is I radical A. See that? So you need to know that, okay? So let me write down here, if you have a radical of -A, so this is I radical A. Good. So now you can evaluate this. So what is radical of -16? You apply that, okay? You know the radical of -A equal to I radical A. Is that right? Use the definition for that. So radical of -16 is what? So if you have radical of -16 is same as I radical 16, right? So what is the square root of 16? What is this? What is the square root of 1? 1, right? What is the square root of 4? 2. What is the square root of 9? Yeah. Radical 16 is 4, right? So it is what? 4i. Got it? Okay, now how do you evaluate radical of -70? Do you know how to do that? Radical of negative 70, right? So use the definition, this. What is radical of negative a? This is I radical a, right? So what will be this? Radical of negative 70 is?
I equal as I times.
I times radical 70, is that right? Now can you simplify radical 70? Is this a square number? 70. Is 70 a square number? You know the square number means, right? 1, 4, 9, 16, 25. No, right? So what you can do, so can you write down 70 as a product of a square number and other number? 70. Tell me, what is the least prime number that divides 70? What is the least prime, you know the prime number, right? The number which is divisible by 1 and itself, like 2 is a prime. 3, is 3 a prime? Yes? 4? No. 5? Is 5 a prime number? Yes, right? So now what is the least prime number that divides 70? 2? Because this is even number, right? It is divisible by 2, right? So what will be here, guys? 35. So what is the least prime number that divides 35? 5, is that right? So now you cannot write down this as a product of what? A square number and other number. So this is the final answer. Did that make sense? Are you guys with me? Okay. So now, hey, let's do radical negative 48. Okay. Are you guys with me so far?
Why did we do the prime number for 70? Like what was?
What's that?
What did we get from getting?
Oh, we didn't get anything from here because I'm just like trying to rewrite this as a product of a square number and the other number, right? You see the 70 is 2 times 5 times 7. So I cannot write, if I do 2 times 7, so it will be 14 times 5. So none of them are square number, right? And then if I do 2 times 5, it will be equal to 10 times 7. And neither 10 nor 7 is a what? A square number, right? So, but you will understand this one, okay? Like, you got it, right? So now, look here. So radical of negative 48. So now use this property. Use this definition, okay? What is radical of negative a? I radical a. So what will be this? Exactly, I radical 48. Now, my question is, can we rewrite 48 as a product of a square number and other number? So now we will use this way. I mean, like, you can do some mental math. So what I like to do is like this, okay? So what is the least prime number that divides 48? 4 is not a prime. Yeah, 2. And then this is 24, is that right? 2 times 24 is 48, right? What is the least prime number that divides 24? 2. What is the least prime number that divides 12? 2. Am I making sense? So let me, okay, you see that 6 now. If you do not look here, this 12 is 2 and then like a 6. Are you guys with me? Right? So what is the least prime number that divides 6? 2. Now we are done, right? Because both of them are what? Prime, right? So now, look here. What you can do here is this is I radical 48 is 2 times 2 times 2 times 2 times 3. 2 times 2 is 4. 4 times 2, 8. 8 times 2, 16. 16 times 3, 48. Did you see that? Look here. I can rewrite this. 2 times 2 times 2 times 2 times 3. Is that right? Right? Now you can see that this is I. Now, hey, can we rewrite this as a product of a square number and other number? Look here. 2 times 2, 4. 4 is a square, right? 2 times 2, 4. 4 is a square, right? Even like if you do 2 times 2 times 2 times 2, 4 times 2, 8 times 2, 16. 16. Is 16 a square number? Yes? So now you can rewrite this as what? 16 times 3. Make sense, guys? Make sense? Now, this is same as I. So you see, this is radical 16 times. So we have a radical, under the radical sign, we have a 16 times 3. Remember, if A and B are positive, so if you have A times radical A times B, you can write radical A times radical B. Okay? Make sense? So now this radical 16, we can rewrite this like radical 16 times radical 3. You got it, right? Right? So what is radical 16? What is radical 16? 4. So now you can rewrite I times 4 root 3, and this is same as 4I radical 3. Right? So now the thing is this, if you have a good mental math, you can easily figure out the things. Like let's say, for example, you have a radical negative 128, right? So if you have a very, very good mental math, you can easily do, hey, this is I radical 128, right? Now, can you tell me? So this 128, can we rewrite 128 as the product of a square number and other non-square number? What is that? You see that? So you follow the same idea. What is the least prime number that divides 128? Is 128 even?
264.
Exactly, 264. What is 64? Is this a square number?
8.
Yeah, 64 is a square number, right? So you can write down the 64 times 2. Are you with me, guys? So this is I, so radical 64 times radical 2, and the 64 is 8I radical 2. Did you see that? Right? Okay. Did I make sense so far? Good. Okay, we can do it. So this is so simple, okay, guys? So if you have this is a typo here. This is product, okay? Radical negative 6 times radical negative 10, okay? So now you have a radical negative 6 times radical negative 10. This is times, okay? Radical negative 6 times radical negative 10. Now, hey, look here. So if you know radical negative A is I times radical A. You know that, right? So now, if this is the case, so can you tell me what is radical negative 6? Use this. Use this definition, okay? So what is radical negative 6? This is I radical 6, right? What is radical negative 10? Huh? I radical 10. So now, hey, what you can do here? I times I. What will be I times I? I square. Now I told you if A and B are both positive, you can use this. Radical A times radical B is same. You use this in this direction, okay? Radical A times radical B equals radical AB. Is that right? So now this I square times radical 6 times 10. Are you with me? Can I do that? So now this is, hey, what is I square? What is the value of I square? Negative 1, right? So negative 1 times, this is radical 60. Now, can you further simplify radical 60? Can you rewrite 60 as a product of a square number and other number? Can you do that? 60. 60. What is the least prime number that divides 60? 2. Is that right? 2 times 30. So what is the least prime number that divides 30? 2. Now look here. This 2 times 2? What is 2 times 2? 4 times 15. Is that right? And you see the 4 is a square number, right? So now it would be, this is negative, because negative 1 times radical 60 is a negative radical 4 times 15. Are you guys with me so far? Yes? And you guys know that this is equivalent to, this is equal to what? Radical 4 times radical 15. Right? Right? Good? So this is negative. What is radical 4? What is radical 4? 2. 2 radical 15. So this is the final answer. Good? You got it? Okay. Good, okay. So now we got it. Negative 2 radical 15. So you can also divide and multiply. You know, it's like a, let's do this. Oh, sorry. Let's do this one, okay. So you have a radical negative 48 over radical 24. You need to divide radical negative 48 by radical 24, and you have to simplify it. Okay. Okay. Hey, radical negative 48. You know radical negative a. So radical negative a equals to I radical a. So it will be I radical 48 over radical 24. Right? That makes sense? So now what you can do here is, if a and b are positive, you can use this. So radical a over b is same as radical a over radical b. Good? So now this is I. Are you guys with me? So this is same as what? You see, this is same as radical A over radical B equal to radical A over B. If A and B are both positive, okay? Good. So now this is same as radical 48 over 24. Did that make sense here? Huh? Does that make sense? Okay, so this is I. So what is 48 divided by 24? What is 48 over 24? Huh? 2? So now the answer, final answer is I radical 2. Good? Okay. So now, you see that, right? So now if you want to write in the standard form, you guys know the standard form is A plus BI. So now look here. So negative 8 plus radical negative 128 over 4. So look here. So you have to write in a standard form, okay? So standard form, that means A plus BI. You have to rewrite in the form of A plus BI. So how do you do that? You have a negative 8 plus radical negative 128 over 4. And you have to write this in this form, okay? Standard form. So remember, this is negative 8 plus, hey, remember we did it before, this radical negative 128, if you use this definition, what will be that? You can rewrite this as what? Can you tell me?
I radical 128.
Exactly, I radical 128 over 4. Right? And now this is negative 8 plus I. And remember this 128, we can rewrite this as a product of a square number and other number, right? Remember we did that just 5 minutes ago. So what will be that? What will be that? Remember 64 times 2. Because 64 is a square number, right? And now this over 4. So this is negative 8 plus I. So this is same as radical 64 times radical 2 over 4. Right? So now this is negative 8 plus, hey, what is radical 64, guys? Radical 64 is? What is radical 64? 8I radical 2 over 4. And now it has a common denominator, right? So this is same as, this 4 is the common denominator, right? So this is same as negative 8 over 4 plus 8I radical 2 over 4. Make sense? Right? So now, so what is negative 8 over 4? Well, what is 8 over 4? What is 8 divided by 4, guys? 2, negative 2 plus 2I radical 2. Oh, you didn't see that? So let me write down here, okay? So now, so this is negative 8 over 4 is negative 2 plus, and you see 8 over 4 which is 2, I radical 2. So this is the final answer. You see, A plus BI, a standard form, right? Okay. Is that good? Okay, so now when you multiply the complex number, if you want to find the sum of the complex numbers, if you have A plus BI and C plus DI, two complex numbers, if you add them up, So if you have a plus bi and c plus di, if you want to add them up, okay, so you will get, you simply add the real part and the what? Imaginary part, like this, okay? And if you want to multiply this and this, you just use FOIL, okay? And you combine the real part and imaginary part at the end, okay? So use the FOIL. So you guys know use the FOIL, right? What is A times C? AC? A times C, AC, plus A times DI, ADI. Are you with? BI times C, BCI, BI times C, BCI, plus B, this is plus, you know. What is BI times DI? BI times DI, what is that? What is BI times DI? Hey guys, this BI times DI, what will be that? BD, and what is I times I? I square, right? So this is BD, what is the value of I square? What is the value of I square? -1. So this is negative BD. BD times -1 is negative BD. So this is when you multiply positive BI with positive DI, you will get negative BD. Now, this is real. This is real. Combine them. Are you with me? So it's going to be AC minus BD, right? AC minus BD. You got it, right? So now, and then, look here, these are imaginary, right? These two numbers are imaginary. You combine them, okay? So if you combine them, you can factor out I. If you factor out I, you have AD plus BC. So this is for the multiplication. Good? Just use FOIL. And keep in mind, I square is -1. Okay? So now you see it's simple. You can add them up, right? You simply add, like, what is 3 plus parenthesis -2? You just add them up, guys. It's simple. You know, like, it's not hard, okay? Let me show you here. You have a 3 minus 4i plus -2 plus 6i. This is 3 minus 4i. You distribute this positive, right? Positive times negative, -2. Positive times positive 6i is 6i, right? Are you with me? Right? Good? So now this 3, you combine this. These are the like terms, okay? You combine them. 3 minus 2. What is 3 minus 2? 1. And now you see -4i and positive 6i. You combine them. They are like terms, right? So what will be that? What is -4i plus 6i?
2i.
Yeah, positive 2i. So this is the final answer. Make sense? Okay, good. So if you want to, like we did that one, you see, yeah, we did that, right? Multiplication of the complex number. So use FOIL. It's so easy, right? You can do that. And now, hey, how do you find this? 4 plus 3i square. So you have a 4 plus 3i, you see, parenthesis 4 plus 3i square. How do you find that? You guys know x square equal to x times x. You guys know that, right? So what is 4 plus 3i square? 4 plus 3i times 4 plus 3i. Right? And then use the FOIL. What is 4 times 4? 16. You can use the FOIL or you can use this formula, okay? It's up to you. But I prefer to use FOIL. It's easier for you. 4 times 4, 16. Plus, what is 4 times 3i? What is 4 times 3i? 12i. Plus, what is 3i times 4? What is 3i times 4? 12i. And what is 3i times 3i? 3i times 3i. 3 times 3, 9. You are right. What is I times I? I square. So this is 9i square. Are you with me, guys? So now this is 16. Hey, these two are the like terms. Combine 12i plus 12i. What will be that? 24i. So this is plus 24i plus 9. What is the value of I square? -1. So now, right? So this is 16 plus 24i, and positive 9 times -1 is -9. Does that make sense, guys? Hey, what is 16 minus 9? 16 minus 9? 7 plus 24i. So this is the final answer. Okay. So now the important thing here, you see when you multiply two complex number, right? Sometimes it will give you a what? Real number. But here it's not a real. Is it real? No, right? It is a non-real complex, right? Right? But sometimes when you multiply two complex number, it will end up with a real number. Let me show that. Let's multiply 6 plus 5i and 6 minus 5i. So you have a 6 plus 5i times 6 minus 5i. Okay? So how do you do that? You just use FOIL, okay? Can you help me? What is 6 times 6? 36, good. What is 6 times -5i? -30i, good. What is 5i times 6?
39.
Positive 30i. Are you guys with me? Yes? So what is positive 5i times -5i?
Negative 25i squared.
Yes, excellent. Right? So hey, what did you see here? What did you observe? This is -30i plus 30i. What can we do? Cancel them, yeah. So now you have 36 minus 25. What is the value of I squared? -1. So now this is 36 -25 times -1. -25 times -1. What would be that? Positive 25. Is that right? Hey, what is 36 plus 25? 61. Is 61 a real number? Yes? Did you multiply two complex number? You multiply two complex number? Yes? And so now we got 61, right? So this is what? This is real number. Is that right? Are you guys with me? So now, if you multiply two complex numbers and we end up with a real number, so they are called conjugate to each other. Complex conjugate. Or you can think in this way. So if you have two complex number a plus bi and a minus bi, if you multiply them using FOIL, you will get a square minus b square. You will get a square minus b square. You see, what is a here? 6. What is b here? Sorry, I think you will get a square plus b square. What is a here? 6. What is b here? 5, right? So if you do 6 square plus 5 square, what is 6 square? 36 plus, what is 5 square? 25. And you see, when you add them up, that will give you 51. Is that right? Right? So now a plus bi and a minus bi are called complex conjugates to each other. You see that? For real numbers a and b, a plus bi times a minus bi equals a square plus b square. And a plus bi and a minus bi, they are called complex conjugates to each other. Make sense? Okay. So now, if you want to find the quotient, let's say you want to find the quotient, you have a complex number divided by another complex number, let's say like this, you see. So now you need to write your answers in a standard form. Okay, so let's do this, okay? So now you have a 3 plus 2i over 5 minus I. You have to find quotient, okay? Find quotient and write the answer in a standard form, right? In the form of a plus bi, right? In the form, standard form means a plus bi. Are you with me? You are going to divide this 3 plus 2i by 5 minus I, okay? And you have to write the answer in a standard form. So the idea here is, guys, you have to multiply. So you have to look at the denominator. We have a complex number 5 minus I, right? Right? So now you have to multiply denominator and numerator by the conjugate, by the complex conjugate of the denominator. Okay? What is your denominator? 5 minus I. What is the conjugate of 5 minus I? What is the conjugate of 5 minus I? What is the conjugate of a plus bi? Remember, what is the conjugate of a plus bi? A plus bi and a minus bi are complex conjugates to each other, right? To each other. Did you get it? So what is the complex conjugate of 5 minus I? So instead, in place of a, you have 5. Did you see that? 5 minus in place of b you have 1. Is that right? Right? So what is the conjugate of 5 minus 1 times I? Look here, a plus bi and a minus bi are what? Conjugate, right? So what will be the conjugate of 5 minus I? 5 plus I. You got it. 5 plus 1. Are you guys with me? 5 plus I. So you multiply denominator and numerator by complex conjugate of denominator. By complex conjugate of denominator. And you know we can multiply numerator and denominator by the same number. Is that right? We can do that, right? Right? Okay. So now, you see what I did, right? So now, hey, let's use the FOIL for the numerators, okay? So you have a 3 plus 2i times 5 plus I. Use FOIL. What is 3 times 5? What is 15, right? Plus, what is 3 times I? 3i. What is 2i times 5? 10i, right? 2i times 5 is 10i. Is that right? And then, are you with me, guys? And what is 2i times I? Yeah, 2i square. And then, in the denominator, you have a 5 minus I times 5 plus I. Remember? A plus bi times a minus bi is a square plus b square. Is that right? Right? What is your a? So this is in the form of a plus bi times a minus bi. Agree? What is a? 5. So 5 is square. Plus, what is b? What? No, b is, remember it has a 1 here, you know, like this I, it is exactly 1 times I, this is 1 times I. Are you guys with me? So what is b? 1. So 5 is square plus 1 is square. Okay? Okay? So what is 5 is square? 25 plus 1. What is 25 plus 1? 26. Now guys, look here guys. So you can use this or you can use FOIL. It's up to you. You can use FOIL also, okay? If you want to use FOIL, 5 times 5, 25. Is that right? 5 times positive 1i, 5i. Right? Negative I times 5, negative 5i. Negative I times negative positive I, negative I square. Does that make sense? And then this positive 5i, negative 5i cancel, and you have this I square is 2 times I square, this is negative 1, is that right? Right? What is 2 times negative 1? Negative 2. Are you guys with me? Yes? So now 15 minus 2 is 13, plus 3i plus 10i is 13i, over this is 25, minus this I square is negative 1, right? So this is 13 plus 13i over 25 plus 1 is 26. So 13 over 26 plus 13i over 26. Did you see that? Okay, so half plus half I. Okay, so now let me stop here. Okay, I'll see you later.